going to find probability of events and experimental probability of events. And then some key terms. The first one is, what is probability? So it's the measure of how likely an event is to occur. Our scale is 0 to 1 or 0% to 100%. So we're going to be writing the probability today as decimals, as percents, and as fractions. And then here are some other key terms that you will notice. So the next one is outcome. So that is the possible results of a situation. Okay, then we have what is called the sample space. That is the set of all possible outcomes. And I'm going to let you write these down, and then we're going to go over some examples together. Okay, so the sample space is the set of all possible outcomes. And then the event is called the outcome or the set of outcomes. So often we'll say, oh, what's the probability of an event? An event is just something that happens. It's not even something grand. So with probability, a really easy thing to reference is flipping a coin, right? What are your outcomes of flipping a coin? Heads or tails, right? Okay, so that's your sample space. The event would be, I'm just going to say rolling a heads. Tossing a heads? Is that what you'd say? Heads up? Yeah. Yes. All right. And then the theoretical probability is based on theory. Okay? When you have equally likely outcomes, so it's important that each event is equally likely. Okay, the probability of the event, this is how you would write it. So it's a capital P, and then in parentheses, event. So the probability of what you want to happen equals the number of favorable outcomes, which a favorable outcome is just what you want to happen. Okay, and that's going to be over the total number of outcomes. Okay, so all of the possible outcomes. So what you want to happen over everything that is possible. All right, so like I said, I'm going to show you this page in your book. And this is something common that we're going to talk about. So they call it rolling a number cube, which is the same thing as rolling a die, okay? And then spinning a spinner. Can you guys think of any games where you use a spinner? Yeah, that's what my next hour said, or my last hour. Yeah, twister. So the sample space, when you have a number cube, is you could roll a 1, a 2, a 3, a 4, 5, or 6. For this spinner in particular, it would be the red, blue, green, and yellow. That's the sample space. And then the event that we talked about was flipping a coin. So we talked about how the probabilities are written as fraction or decimals from 0 to 1, or as percents from 0 to 100. So impossible would be 0%. Like there's no way it could happen. And the certain would be it's definitely going to happen. Okay? And then you probably heard, oh, there's a 50-50 chance. So it's just as likely not to happen as it is to happen, which is the tossing of heads or tails. Okay? And then I told you that we're talking about theoretical versus experimental. The coin toss is actually a really nice way to experiment with that. So if you were if you were tossing a coin, okay, and you tossed a coin 10 times, how many times out of 10 should you get tails? 5. Theoretically, you should get 5, right? Okay, you have a 1/2 chance. Okay, but have any of you tossed a coin 10 times? They should. We didn't have 2 snow days. I would Now you have a experiment that's fun. So if you toss a coin 10 times, right, are you always going to get 5 out of 10? Nope. That is experimental probability. So the experiment, what happens when you try it, versus in theory what should happen, that's the difference between them. Okay? So the first thing we're going to talk about is theoretical probability. But first, sometimes it's really difficult to calculate an event not happening because there are so many choices. And in cases like that, we're going to use something that's called the complement. So that's the probability of an event not happening. Okay, so if the event is E, the probability of that not happening, okay, and an example would be, oh, the probability of us not tossing the heads, right? Then you would do 1 minus the probability of the event happening. Okay, so if we used our 5 out of 10 example, right, if this what it was for heads, okay, then to find the tails, you would just do 1 minus 5 out of 10, which again is 5 out of 10. Okay, and we'll practice that. I just wanted to give you a little preview of what it should look like. All right, so for example 1, we are going to talk about some English things. We'll see how you guys know some of your vocab there. So each letter of the word probable, probable is written on a separate card. The cards are placed face down and they are mixed up. What is the probability that a randomly selected card has a consonant? Do you guys know what a consonant is? Do you know what it's not? It's not a vowel. Good. Okay, so remember, probability is going to be the favorable over the total. So the favorable is going to be the consonants in this. So I always set up my fraction, blank over blank. We're just going to label what these are. Okay, so on top, I'm going to put the consonants, not vowels. And then on the bottom is going to be the total letters. All right, so how many total letters are there in probable? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then the not vowels, we know vowels are A, E, I, O, U. So the not vowels, let's just go through them. So what about P? Yep, what else? R. What's the next one? B. And then B actually happens again, so we do count that twice. And then L. Good. So we have 5 over 8. Okay, and then when we write our answer, we're going to write it as a fraction, a decimal, and a percent. Okay, so as a fraction, you want your fraction reduced. As a decimal, we are just going to divide, so you can use your calculator for that. 5 divided by 8. And then do you guys know how to turn a decimal into a percent? How do you turn a percent or a decimal into a percent? What do you do? Yeah, multiply by 100, which is just moving that decimal how many places? 2 to the right. Yep. So this would be 62.5%. All right, great. Now for example 2, 2 number cubes are rolled. What's the probability that the difference between the 2 numbers is 4? What's the difference? What's the probability that the difference between the 2 numbers is 4? Okay, so again, we're going to do the favorable out of the total. Okay, now, just going to put fav over total. in your book, on page 491, there is this awesome chart, okay, that shows you all of the different combinations. So remember, a number cube, this is like a pair of dice, right? So if you roll a pair of dice, you could have 1 and 1. The first die could be a 1, and then you could roll another one. You could roll a 2 and then a 1. You could roll a 3 and then a 1, 4, 1, 5, 1, 6, 1. Okay, and it goes through all the possibilities. If you look here on the red, see how it goes 1, 2, 3, 4, 5, 6. And here it goes 1, 2, 3, 4, 5, 6. Okay, so these are all of your possibilities. How many are there total? 36. Okay, so 6 in the rows and in the columns. So 6 times 6 is 36. So 36 is going to be your total number. Now what we have to do is we have to find the ones where the difference between them is 4. Okay, so can you guys think of one right away? Without looking at it. Okay, so 6 and 2 would be 1. Okay, so one option would be to roll a 6 and then a 2. Now, you could also, so this is with the first die is a 6, the second one is a 2. You could also roll a 2 and a 6. Okay, so both of those would have a difference of 4. Okay, difference of 4 between them. What's another combination?
5 and 1.
Good, so you could have 5 and 1. Are there, is there another one? 1 and 5. Anything else? So remember, it only has 1 through 6. Okay, so could I do 4 minus anything to get a difference of 4? It would have to be 4 minus 0, so that wouldn't work. Okay? All right, so there are 4 favorable options. So you have 4 over 36. Okay, again, that 36 is something that you're going to be using over and over again. When you write your fraction, you have to reduce it. So what goes into both 4 and 36? Yep. So this is going to be 1 over 9. And then with this one, your decimal is repeating. So you can just round to the thousandth, or if you want to put the 0.1 repeating, that's fine. And so this is approximately 11.1%. Really, this is the approximate when you're rounding. Okay, so a fraction, decimal, percent. All right, can you think of any questions for me on the first page? Uh-huh.
So I find my answers really have to write out like 1 minus equals to 4 and 1 equals to
Yes. No, put all 3.
Okay.
For different problems, like when you get to your test, you'll have to write them in different forms. And the fraction is going to be one of the most common forms. Yeah, the difference. Yeah. Yeah, sometimes they'll ask you for the difference, sometimes they'll ask for the sum or the product. All right, for the next example, there are 25 students in study hall, and the table shows the number of students who are studying a foreign language. We're going to fill in the table. That will be something that's given to you. And then we have to find the probability that a randomly selected student is not studying a foreign language. Okay, and there are a couple different ways to do this. We're going to use a special technique. These numbers are small enough where you could do part of this in your head. So the one thing you definitely want to focus on is the total number of students. So there are 25 students in the study hall. Okay, and then the number of students when the foreign languages are broken up into these 3, French, Spanish, Japanese. So how many students total are studying the foreign language? Close? Or exact? Sorry. Okay, so you have 21 total in the foreign language. Okay, so you have the probability of the ones that are taking the foreign language. Okay, and that is 21 over 25. Okay, and it's over 25 because that's the total number in study hall. And then to find the percentage who are not taking a foreign language, you can use the complement. So because you want to find the probability of them not doing it, the complement means you can subtract from 1. Okay, and really, you could subtract beforehand and then do it. I want to show you how to use the complement here, especially when you have bigger numbers, like these are kind of small. So all we have to do is 1 minus 21 over 25. Whenever you're subtracting from 1, think of this in terms of the denominator. So what over what would be equal to 1? 25 over 25, right? So all you're doing, and you don't have to write this step out like when you're doing your homework, this part, because we should be thinking, oh yeah, it's just 25 minus 21. Okay, so 4 over 25. And then, can you reduce 4 out of 25? Nope, so let's find our decimal. And yep, you're going to have a fraction, you're going to have a decimal. If it's an exact decimal, I'll write the equal sign. And then if it's approximate, I'll do the squiggles. And then the percent, 16%. Okay, so only 16% of the kids in study hall are not studying the foreign language. All right, so next is example 4. This is going to tie in a few concepts from yesterday. So each student receives a 5-digit locker combination. Is that true? How many digits are you getting in your guys' combinations? 3? That's what mine was. That's what I think most of them are, right? Okay, so they receive a combination with all odd digits. That's what we want to find the probability of. Okay, what's the probability that they get a combination with all odd digits? Okay, so remember, we're doing the probability of the favorable over the total. So the total is going to be the total amount of possible passwords, which, do you guys remember how to do that from yesterday? You guys remember? What do you think? Yeah, there's 10 digits, and how many different, I like to set up my spaces, right? So if it's a 5-digit locker combo, if it's a 5-digit locker combo, then how many digits do you have for the first one? 10. What do you mean? Yeah, their lockers are different. I'm thinking of, you know how there's some of them where you line up the numbers? I'll see if I can find a picture of it. Yeah, because the locker combos that we have, you could have a double-digit one, right? Yeah. I wonder if they're 5 over better. You know, like 26 would be like 2 6.
Like there's some of those lockers that have like a keypad on them.
Oh, okay.
Like right near Mr. T's room, I think so.
Oh, okay. I'm going to check this out. And then when you're doing this in your calculator, because it's 10 each time, you can just do 10 to the 5th. And if you're doing that without a calculator, do you guys know what the trick is? 5 zeros, that's right. Okay, so that's the number of possibilities when you have the 5 digits. Okay, 100,000. Okay, that's your total. Now we're going to talk about the favorable. So the favorable is what we're finding the probability of, is that they're all odd digits. Okay, so how many odd digits are there? All right, let's go through them. What are the odd digits? 1, 3, 5, 7, and 9. So there's 5, right? So you have a choice of 5 for every single space. Okay, so then you can just do 5 to the 5th. And that is 3,125. Okay, so now we're going to do our fraction. So 3125 over 100,000. Now, if you have to reduce a big fraction like this, I'm going to give you a couple of tips and tricks here. The first thing I would do is see if the top number goes into the bottom number. So let's see if this goes in there. Do you guys know another number that we'd want to try if this doesn't work out? Yeah, why 5? Adds in 0 and 5. Yes. So like knowing those rules can definitely help. All right. Does this go in there? What do you think? Yay, 32 times, so we're going to reduce to 1 over 32. Okay, so anytime you do the fraction, you just want to make sure you reduce it. Okay, so 1 over 32, and now we're ready to find our decimals. Okay, so this is an exact decimal, so I'm going to leave it as 0.03125. It's not going on forever. And then when I move it 2 places, it's 3.125%. So that's the percent chance of getting all odd digits. Good, because I like even numbers. Do you guys have a favorite type of number? Even versus odd? Easy ones?
1 through 10.
Yes.
I have a question.
Yeah.
10 to the 5th, shouldn't there be one more zero?
Nope. So if you're doing 10 to the 5th, there are going to be 5 zeros. 10 to the 6th, there'll be 6 zeros. So 1, 2, 3, 4, 5. You're welcome. All right, now example 5 is also going to bring up some fun memories from yesterday. So a DJ is selecting 2 out of 8 ads to play before her show, and 2 of the ads are by a local retailer. What is the probability that she will play both of that retailer's ads? Before her show. Okay, so again, we're finding the total, and then we're going to find the favorable. Okay, so there's 2 different ways that you can find the total. Okay, one way is to think about if the order matters or if it doesn't matter, and then you can use a permutation or a combination. So when you're playing the ads, do they go in a specific order? So there's one ad play first and one ad play second? Yeah. Okay, so you don't take them together, it's one at a time. So the order does matter because they are going in a time sequence. Okay, so, and I know that can be kind of hazy sometimes, but you could use 8P2. So out of 8 possibilities, you choose 2 of the ads to play that are the retailer's ads. Okay? What might be better for some of us is to think of it as, okay, she gets to play 2 ads, right? How many choices does she have for the first slot? 8, because she hasn't played any yet. Now that she's played an ad, how many more does she have for the second slot? 7. Okay, so either way you do this, your total is going to be 56. You might like this way better, and that's fine. I kind of like that way better for things like this. Okay, and then the favorable is that she plays one of, or both of those retailers' ads. So if it's from that retailer, right, again, there's 2 spaces. Of that retailer, how many options does she have to play? 2, because they have 2 ads, right? And then, so the second option would just be 1. So the favorable is the retailer's ads. Okay, and then now we just have to make our fraction. So the probability is the favorable 2 over 56. 2 goes into 56 how many times? 28. Yeah, and then let's divide. Okay, and then because this is a long decimal, we're just going to round it to the nearest thousand. So 0.03, and then the 5 has to round up because of the 7 behind it. Okay, and that would be about 3.6%. No chance of that happening. All right, our next problem is for those of you who missed geometry. Last hour, somebody goes, I don't miss it that much. Come on, you'll like it. Really, this is honestly one of the simplest parts of geometry. I won't ask you to prove 2 lines are parallel, okay? All right, so you have you have a figure that's created by placing a rectangle inside a triangle, inside a square, which is shown over here. Okay, and then if you're choosing a point at random anywhere inside this square, okay, so any point inside this figure, what is the probability that the point is inside the shaded region? You guys can see, like, this is lightly shaded, but I think it could use a little more shading. So this is the shaded region. It's the triangle part minus that rectangle there. This is your shaded region. Okay. All right, so what we're going to do is find the probability that the point is inside the shaded. So in this case, our favorable is the area of the shaded region. So we're just working with areas today. Not scary, right? Wrong. Is this thing on? Wrong. Has any of your teachers ever done a mic drop? I was thinking about that the other day. Just tell a joke. Oh, I do have a riddle for you guys today. You ready? Okay. I am an odd number. If you take away a letter, I am even. What?
Let me do this one.
Yeah, do you know? No?
7.
Yes. Because you were really close. You took away 1, 2. That'd be what? Yeah, so, Brianna, you want to explain it?
7 from S to B, E, N.
Yes.
Take away the S,
It's about even. Isn't that great? You
You
want to know who told me that joke?
I was going to say 5. The internet?
No. Mrs. Brunschweiler's little boy, Diego. That is so cute.
Oh, I thought you were always there.
Yeah! Alright, so the total area The total area is the area of the square, okay? So to find the area of the square, you can do the side times the side, or you can just do the side square, right? What is our side length for this square? 9. See, look, on this side you have 3 plus 3 plus 3. That will be 9. This side is labeled 9. Okay, so you just have to do 9 squared, which is 81, and then it's the area, so it's centimeters squared. Okay. All right, now we're going to find the area of the shaded region. So the area of the shaded region is equal to what? How are we going to find the area of the shaded part? Good. Triangle minus rectangle. So do the area of the triangle minus the area of the rectangle. All right, so all we have to remember is how to find the area of a triangle. What is that formula?
1/2 base height.
Louder, Seth, I couldn't hear. I'm just teasing him because I got him for you. Glenn, you're next. So 1/2, and then what is the base and the height?
Base 9.
Yeah? What's the height? 9. Yes. Because top to bottom, look, it'd be 9. Top to bottom. Okay? So, this is 81 cut in half. It is a nice decimal, so we're just gonna leave it as 40.5. All right, and then we're gonna do the area of the rectangle, which is length times width. So in this case, it is what times what? What's the length and width of our rectangle here? 4 and 3. 4 times 3. So we have 12. All right, so now we're just going to plug them in. So 40.5 minus 12 is going to give you 28.5 centimeters squared. Okay, and then we are ready to make our fraction. Now, if you're making a fraction here, you can't have decimals in your fraction, so you could multiply by 10 in the top and bottom, but what's actually a quicker way, because you're going to have a smaller number? Yeah, multiply by 2 over 2 to get your fraction, and then we'll reduce it. Okay, so you get 57 over 162, okay, and then do you guys know how to tell? So we know that 2 doesn't go into 57 because it's not even. Do you guys know to tell right away if 3 goes in there? You add the digits together. So what's 5 plus 7?
12.
Does 3 go into 12?
Yeah.
It's going to go into 57 then. Okay, and then, so, yeah. All right, so let's try this one. So 1 plus 6 is 7. 7 plus 2 is? So we go into 9? All right, then it goes in there. I just blew your guys' minds today. Yeah. So you just add the digits, and if you add the digits together, if that number is divisible by 3, then your original number is. But really, did some of you guys know that, though? Yeah, good. I can tell by his smile. All right, great. Great. All right, there's one more thing that we're going to talk about today, and that is experimental probability. So when you are performing an experiment, okay, you're conducting some type of an experiment. In this case, it is spinning a spinner, and then there's going to be a record of what happened during the experiment. So for this example, okay, experimental probability is the number of times an event occurs over the number of trials. Okay, so it's still really the favorable over, the total. Okay, it's just this is based on an actual event happening. So in this example, the table is showing the results of a spinner experiment. Okay, remember your spinner would be something like this, where you have 1, 2, 3, and 4, and the little spinner guy. Okay, so they performed an experiment with this spinner. This was based on numbers, and then this is how many times it occurred. Okay, so the occurrence is going to be the trials. So we have to find the total number of trials, so we're going to add up this column. Why don't we add up this one? Yeah, this is just the label, right? So the number 1 was spun a total of 6 times. Okay, so we're just going to add these together, 6, 11, 19, and 14, and the total is 50. Okay, so we just add those up. Okay, and then so we're going to find the experimental probability of spinning a 4. So if we go here, the number 4 was spun 14 times, so it's 14 over 50. And then again, anytime you have a fraction, make sure you reduce it. So this is going to be 7 over 25, okay, which is going to be, let's find it, 0.28 exactly, which is 28%. Okay, sometimes the events can be a little bit tricky, so read these carefully. This is spinning a number greater than 2. What numbers on the spinner are greater than 2?
3 and 4.
Good. If it said greater than or equal to 2, that's when you would include it. Yeah. Okay, so to combine these, all you have to do is add them. So 3 was 19, this was 14, so we're going to add the 19 and 14, and it's still over the same total. Okay, so we have 33 over 50. And then we're going to find our decimal. And again, this was an exact 1.66, so 66%. Okay, and then go ahead and do the spinning the odd number. And then think of your own event to create. I'll take some suggestions and we'll do one of them together. Okay, so what are our odd numbers on the spinner?
1 and 3.
Yeah, okay, so then what do we do? Yeah, 6 plus 19 over 50. And then we have to reduce, so 25 over 50 is 1/2. So 1/2 equals 0.5, which equals 50%. Okay, what's another event we could do together?
Spinning a 1.
That. All right.
What, you want?
That's fine. Spinning a 1.
Number greater than 0.
Yeah, spinning a number greater than 0 would be
Spinning a number
100%.
between the numbers.
Okay. Oh, I know. I want you to do this one, and then we'll skip E, but I want you to do this for D. Okay. I want the event to be not spinning a 4. So if you're not spinning a 4, there's 2 ways that you can do that. See how you already found the event of spinning a 4? See how you already did that, spinning a 4? So this is where you can use the complement, okay? You could also just add them all up, but if you do 1 minus the probability of spinning a 4, because that's something you've already done, okay, you can just do 1 minus 7 over 25, right? Because you already found it. Okay, so this is like 25 minus 7, which is, yes, so it's 18 over 25, and then find your decimal, which is 0.72, which is going to be 72%. Okay, now I'm going to give you your homework, and I'm going to give you the rest of the time to work on this. So your homework is a packet, and it's mandatory. So there's a 7.2 packet. Okay. You can see that some of these problems are going to go very quickly. Okay, so I'm very confident that you can finish the first page in here.
Who's hungry for lunch? What do you guys got for lunch today? Grilled cheese.
I have a quesadilla.
Homemade.
Homemade, I made it. Oranges. Can't remember the other thing. And I think
Sam?
your dad said
My mom packed mine.
what?
No, I got one of those things where it's like the cheese and the crackers.
Cheese and
It's
crackers.
like
That's
the organic.